Okay, so we're on the last part of topic 3, where we've been talking about the transformation of functions. Today we're going to further study the lateral transformation of a function. That means the side-to-side transformation. It's actually called a translation. So here we have a quadratic form, the most basic one, just squaring x. And here we have it tabulated. -3 goes to 9, so on and so forth. And you see that it's symmetric. So if we want to shift this to the right, we talked about writing this as the initial function minus the right translation or plus the left translation. Now we're going to look at it from the other direction. We're going to apply the translation to the translated function g. The first thing to notice is here's a list of the argument of the function, and here's the function value itself, which we plot along the y-axis. We're going to shift this to the right 1. This is the original quadratic function here, x squared, and we're going to see how the translated function changes as we shift it. Okay, so we've shifted it once. All of the arguments went up by 1, and our highest one has changed from 3 to 4. Our function has, the value of the function has not changed. So we'll move it over again. So the argument is changing and increasing. Again, the argument, the variable in the function is changing, it's increasing, but the function is still maintaining its form. So we could write this like this. Here we write the translated function plus the shift to the right equals the original function, f. So again, we see that the g values do not, as the function is shifted. Okay, so we're going to look at this in this animation form. So the value of g at this point we'll call a prime, and it's equal to a, which was the value of the function f at x. So if we have this form, if we say f of x equals g of x plus h, which they write here, this is a corollary. It's the same thing as the way we were writing it last week, which last week we were writing it f of x minus h, where h is the translation to the right, equals the new function g of x. These are equivalent expressions. So let's look at the equivalent expressions here. It's true that if f of x minus h equals g of x, then g of x plus h equals f of x. So this has a symmetry in it. Again, if the original function minus the right translation equals g of x, then you can also write that the translated function g of x with the translation added directly to the argument equals the original function. These are corollaries, or these are the same expression, or the same idea.